first examples where innovation really drove to a significantly more sustainable process. The latest MSD development strategy is that we really try to develop the best chemistry at time of regulatory filing, and we have the ultimate goal of a zero-waste API manufacturing process. And the way we want to do this is that we are looking for innovative, green by design development strategy, and we go from an initial route design through to a fully optimized, sustainable commercial manufacturing process. How are we doing this? So what we do is we design for the atom economy right from the beginning. We invent new transformations if we have to, and we optimize then for sustainability. And the way we achieve this is with high throughput and with predictive science as well, which is maybe this makes it a little clearer here. What we do is we look at the synthesis, we look at the manufacturing process, and we, as a chemist, we have brainstorming to see what is the best way of putting this molecule together. What is the most economic way of putting this molecule together? And once we have the bond formation finalized, we then look with predictive science, and we look with chemical intuition as well as with high throughput screening. We look if these reactions we need in order to do the transformation, if they are doable. And I said, often they are not known in the literature. But the way we are doing it, we are trying them in high throughput. We have a lot of in-house reagent libraries, and also these reagent libraries, they are based on sustainability and on green reagents. And then what we do is we go in the execution phase, and as you can see, this is a dime, and that shows you how small or how big these files are. So we can do this high throughput experimentation with milligram of material. And we then analyze it depending on what we see. We do further process development, and then we go in cycle. And as said, we can do this iterative development and optimization with gram material. And we can do this within a couple weeks. So this really also hopefully answers one question, well, it takes so long. I think by using this technology and combining it all, predictive science, so what we do is once we have data, we feed these data into, for example, we are looking maybe for a catalyst, for an organic catalyst, and we have some hits, and then we feed it into the computational design, and then we come up with new molecules. And then we go whatever the design tells us, and we make these molecules. And this has shown that this can be very successful. It's relatively short time, and it doesn't really need a lot of material. And this is what comes out when you do that. So this is one of our latest examples. This is letermovir, an antiviral drug candidate. It's currently in phase 3. The original process didn't really meet the MSD criteria. It is a compound which was bought, and so it came with a process which had a PMI of 700. It had a 10% overall yield. We're using 9 different solvents. I mean, 9 different solvents. That already tells you that you have to do a lot of distillations and solvent swaps. And it was very high in palladium, loading 20 mol% there. With the technique I showed you, with the high throughput experimentation, with the computational computational modeling, we were able to come up with a new process. And as you can see, we now have a 75% overall yield. We have a PMI from 700 to about 100. You see this here, the comparison. So we have a reduction from 73%. And we have a through process, and we only now have two solvents, isopropyl acetate and toluene. And it's very much less energy intensive because we have minimal solvent distillation. And you can see here the life cycle assessment data. So the water reduced is reduced by, we only have 10% here. And the global warming potential is now 11% from the original process. And also, if you look at the raw material cost, I mean, we have a decrease of 93%. So I do think that this is a lot of value creation. But with incremental changes, you are not able to do this. You really have to look for new chemistry. You have to look for innovation in order to be able to get these value and these gains out. And as said, at MSD, we try to do this now for all our manufacturing processes because we, in the past, we had these post-approval changes, and I think everybody knows how painful these post-approval changes are. And here, just some key considerations. I think it's worthwhile and a lot of value added to look for material efficiency improvements. They can often help reduce the product and waste disposal costs. And as seen, I think it's clear the lower the PMI, the lower the costs. Also figuring out how to use less water is critical because we don't know where our future products will be made. And there are countries where water is not abundant. And then also, I think this is very important, ambient reactions and thermally stable products will reduce the energy needed to make, store, and to transport them. And that was really my last slide, and I really thank you for your attendance.
I guess we're short of time, but certainly time for a quick question. Okay, no question. Great, thank you, Dr. Ingrid Mergelsberg. I will be requesting, yes, of course, round of applause, please. Can I request one of our delegates, Dr. Ashutosh Agarwal, he's here, CSO to kindly CSO Jubilant Life Sciences, to kindly felicitate our speaker, Dr. Ingrid. Thank you for joining us. Sorry.
Thank you.